So we'll start off from the basics. What is integration? In simple words, it's the reverse process of differentiation. While differentiation is used to find a gradient function, integration is used to find the equation of the curve, or it may also be used to find the area under the curve or the volume generated by the curve given that we rotate it. But these are advanced things. First of all, let's start by finding the equation of the curve. We'll understand integration through a few models, which is my word for steps. So first of all, starting off with the basics, we have no coefficient with x and we only have x to a power. So the generalized differentiation would be, first of all, put the integration sign, and the equation of the curve turns out to be increase the power by 1 and divide by the increased power. And to retain the place value of the constant that was dropped during differentiation, we put a C. I repeat, to retain the place value of the constant that was dropped during differentiation, we put a C. If there was no constant dropped, the value of C would turn out to be 0. But usually there is a constant. Moving on, let's take numeric examples. In this case, put the integration sign and the equation turns out to be increase the power by 1 to become 4 and divide the function by 4. And to retain the place value of the constant that was dropped during differentiation, put a C. Again, with the integration sign, increase the power by 1 and divide by the increased power. And put a C to retain the value of the to retain the position of the constant that was dropped during differentiation. Similarly, with a constant sign again, the equation of the curve half plus 1 would turn out to be 3 over 2 divided by 3 over 2, and we put a C again to retain the place value of the constant that was dropped during differentiation, and we turn out to have 2/3 and x to the power 3 over 2 plus C. Moving on, this is also part of basic differentiation where we only have a constant. This is the simplest case that can exist, and we'll write this as the constant with an x. We had an a and we'll turn out to have an ax, given that integration is with respect to x. Alright, with respect to x. If it was integration with respect to y, we'd put a y. Alright, but in this case, the normal scenario is with respect to x. The background is that in the first case, nothing exists with a, so it's 1, and 1 can be written as a x power 0. X power 0 is 1. Alright, so this was the given dy over dx. We put the integration sign to turn out with a x 0 plus 1, that is a x plus 1. And always remember to put c to retain the place value of the constant that was dropped during integration. I repeat. And also divide by 1. Always remember that too. That's the basics. Alright, these are always the basic steps. And in this case, integration sign everywhere, since we have to integrate with respect to x, this would turn out to be 5x plus c y 12x plus c y x plus c. Moving on, continuing with the basic differentiation, let's say we are given this, where we have a coefficient of a variable. So again, nothing is going to change. We have the integration signs as they are. dy over dx turns out to be y. Since we are integrating, increase the power of x by 1, divide by the power and plus c. Not a single step change. And this was, by the way, an extension of the previous model. Moving on, let's take two examples. With the integration sign, dy over dx turns out dy over dx turns out to be y. Increase the power by 1, divide by the power, increased power, and put a c in the final step, or in the first step too, if you want, to retain the place value of the constant. C must be in your final answer, and it does not matter much if you put it or not put it in the intermediate steps. Alright, moving on our second example, integration signs. Y, increase the power by 1, divide by the increased power, and we have 2x squared plus c. Now I'd further like to elaborate on c, that is, we added to retain the place value of the constant that was dropped during differentiation. I'm always repeating this, but you need to understand that. Let's say we had y, that's the equation of the curve. We differentiated it and notice that we dropped this constant, as the differentiation of this constant was 0. So we did not write it. But if we have to integrate this gradient function, and we know that that integration is the reverse process of differentiation, we expect exactly this equation. So the first step in obtaining exactly this equation is writing C. Yes, exactly, writing C. And then in order to find the value of C, the fixed value that we expect to be minus 3, we need to substitute a point on the curve. Let's say we are given 1, 3, so we substitute x as 1 and y as 3 and obtain solve for C. And finally write the final equation of the curve. This is our last model for basic integration. So the first step is, again, if we were to differentiate this, we bring the power down, reduce the power by 1, and yes, multiply by the differential of the bracket. But in this case, we are not differentiating, we are integrating. That is, we will increase the power by 1 rather than subtracting it, divide by the increased power rather than multiplying it, or yeah, bring it down. So, and finally, multiply the denominator with the differential of the bracket. That turns out to be a. And that's right, put a c to retain the place value of the constant that was dropped during differentiation. Moving on, in this case, we have phi x plus 1, increase the power by 1, write that increased power in the denominator multiplied by the differential of the bracket, and our final answer turns out to be phi x plus 1 power 4 over 20 plus c. Our last and final example of this class, first of all, we put these curved brackets, or whatever you call them, the sign, integration sign, and in this case, we need to perform one more step before we can integrate it. That is, we will have to write this as 2x plus 1 in the numerator. We'll have to bring this to the numerator and write it as minus half. Alright, since we brought it to the numerator and the square root is half. And the signs stay as they are. We'll increase the power by 1 and it turns out to be half. Divide by the increased power multiplied by the differential of the bracket. And this turns out to be our final answer. 2x plus 1 plus c. And this is where we wrap up basic differentiations. Never, and just let me clarify that this is not the end of integration, but we will have future videos where we'll cover advanced concepts. That's it.